Hello, my name is Professor Chukamoye. I'm a professor of regenerative chemical process evaluation and empirical modeling. Today, I would like us to talk about iron ore dephosphorization. Phosphorus has been known all over the world to affect the steel integrity. Engineering materials produced from iron ore normally fail in service due to embrittlement if it contains phosphorus above the admissible value. So there's need to remove this phosphorus to ensure a better steel. Several work has been done in this area, and some people came out with models, equations to at least show that phosphorus can be removed as a function of several parameters. In this work, an empirical model was derived, as you can see on the screen, where phosphorus removal is a function of the initial and the final solution pH. This is the parameter for removed phosphorus concentration, which is calculated in milligram per kilogram. This is the initial solution pH and the final solution pH. Now, in model 1, we want to solve a problem. And the problem is calculating the phosphorus removal when the values of the initial and the final solution pH are given. And so, if you substitute these values to the empirical formula, empirical model, you have this expression. Now take note of the ratios of the pH values to which an exponent is placed below. Now, on evaluating equation 1, we have equation 2 where the bracket is exponential of 1.25. 1.25 is the evaluation of the ratio of the initial and final solution pH. And so phosphorus removal is now equal to 4.25 in bracket multiplying exponential 1.5 all cubed. Now, on expanding the exponential of 1.25, we'll have 3.4903. And when you multiply all through this expression, we have 4.25 multiplying 42.5195. And so the phosphorus removal as evaluated is 180.71 milligram per kilogram. In model 2, the problem in this case is to evaluate the final solution pH when the values of the phosphorus removal or values of the concentration of removed phosphorus is known, and also the initial solution pH is known. And substitute these values into the model, we have that 150.24 is equal to 4.25. In bracket, we have exponential of 0.6 over the final solution pH. And upon expanding further by dividing both sides by 4.25, we have 35.3506 to be equal to exponential of 0.6 over alpha, all cubed. Now, there is need for us to open the bracket. And for us to do that, we need to find the cube root of both sides. And when we do that, we have 3.282 to be equal to exponential of 0.6 over the final solution pH. Still at that, In order to open the bracket, we'll need to get the exponential of both sides. So that we'll have, what we'll have left will be this. This is what we'll have when we find the natural log of both sides. That's what we're going to have. And that is 1.1878 to be equal to 0.6 over the final solution pH. And eventually, the final solution pH is 0.51. Now, in Module 3, the problem to be solved here is to calculate the initial solution pH if the concentration of removed phosphorus and the final solution pH are given. And when we substitute these values into the model, we're going to have 197.5 is equal to 4.25. Then a bracket, we have an exponential of the initial solution pH, which we are looking for, divided by the final solution pH, all cubed. Now, in order to also help in expanding the bracket, we will need to divide both sides by 4.25. And so we have 46.48 to be equal to exponential of the initial and the known solution pH over the final solution pH cubed. The next thing we are going to do will be to find the cube root of both sides. And that will give us 3.595 to be equal to exponential of the initial and the final solution pH. And so, in order to now remove the exponential, find the natural log of both sides. And when we do that, we have 1.2795 to be equal to the initial solution pH all over the final solution pH, which is 0.56. And on evaluating further, we shall have that the initial solution pH is 0.72. For reference, you can check the model source, which is called from this online source for references and to know how further work was done on this. I want to sincerely thank you again. The instructor remains Professor Chukwuemoi. Please kindly subscribe to Metalo Math eLab. Thanks for watching. Bye.